Hey everybody, welcome to Data Skeptic. Today on the show we'll be talking about the Onyx format. It's an open and interchangeable file format for storing deep learning models. Before we get to that, I want to remind all the Data Skeptic members, coming up quick, Sunday, July 28th, 11 a.m. Pacific time. We're going to do a hangout of some kind, and I will shoot you an email later this week. If you don't hear from me, absolutely feel free to reach out directly after. I'm going to give myself till the 25th. If you don't hear from me by the end of the day, 25th, hit me up just to make sure we haven't screwed up a list or something. But everybody should know the details. I'll shoot you an agenda for the kind of stuff I'm going to cover. Most notably, our new theme on Data Skeptic as we wind down natural language processing. This interview's fairly technical, but I think also easily accessible with a little bit of background. So feel free to skip ahead 30 seconds a few times if you're one of the more senior listeners. Otherwise, let me tell you about YOLO, BERT, Protobuf, and a few other things very quickly. So there are a variety of frameworks in which a person can do deep learning. TensorFlow, PyTorch, Caffe, Keras, although that's kind of a special case almost. Things are moving fast in general. And what's been very interesting about the technology is it doesn't seem to me anybody's trying to lock you down, use our proprietary format and our proprietary tools. That's an old model. If I'm, on or near the cutting edge, am I going to build something that some monolithic technology company is then just going to build a way better version of? I work with a lot of companies that built their own quasi-Kubernetes before there was Kubernetes. And now it's this awkward tech debt that they have to work with. Although you do have to give credit to the point of, if it's working, it's working. But that aside, even deployment of classic machine learning is surprisingly not easy. I wouldn't necessarily call it difficult, but you think it would be easier. At the time you finish your model, you've run all your diagnostics and you think you're good to go, to have some sort of push-button, continuous integration, continuous deployment thing. And there's, a dozen or so tools that do that or claim to do that, and your mileage may vary. But hosting deep learning models is especially tricky because they're much bigger. You train a logistic regression model. That model is expressed as a vector of all the weights, quite compact, probably. Even your biggest sklearn model or XGBoost built in Python. Do a bunch of fancy stuff with ensembling and stacking and really bloat that model. You're still probably only looking at a couple hundred megs, I would guess, in most cases, at least my experience. There's lots of easy ways to turn that into an API or embedded or something like that. But at Data Skeptic HQ, we've also been messing around with BERT lately, and we're going to need to do one, maybe even 2 episodes on BERT. I know, it's coming. Be patient. That'll be our little capstone for this run on natural language processing, I guess. But BERT is a deep learning model. There's 2 publicly available versions of it, BERT Large and is it BERT Medium? But you got 2 sizes, whatever you call them. One, I believe, sits in memory at around 8 gigs, the other around 16, I want to say. So if you want to make that an API or a service, there's a few hoops to jump through to make that happen. And there's some great projects on GitHub, stand on the shoulders of giants and all that. But there's a lot of plumbing here and seems like a lot of techniques in motion. That's why I was glad to have a chance to feature the Onyx format in this interview. While we don't explicitly talk about it in the context of NLP, I would hope if you've learned one thing this series, if you've learned one thing, hopefully it's large corpora are more powerful than fancy algorithms. That's sort of the number 1 NLP lesson. Number 2 is that deep, unsupervised approaches seem to have quite a bit of value. I guess number 3 important point is transfer learning, and I'm so glad I got to interview Sebastian Reuter about that. But after all those points, let's talk about how you deploy this stuff. And it's non-trivial, but an interchange format like Onyx gives you a lot of leverage in building it one way and deploying it another, or ambitious people offering services that support it. So those are my thoughts on Onyx and why I like it. So we touch on BERT. As I said, I'll cover BERT in more detail. For now, the 5-cent explanation is BERT is basically magic. In goes any amount of text, out comes a fixed-length numeric vector that is unbelievably useful in natural language processing tasks. As we covered recently, it's essentially a form of automated feature engineering. Okay, moving along, we mentioned YOLO. This, best to see it to believe it. Just Google YOLO. If that doesn't work, YOLO ML AI. You guys are smart, figure it out. You've probably seen it. It's a quite impressive real-time object recognition system that can run on all these edge devices, things like PIC, I don't know if it runs on a PIC microcontroller, but I think it runs on Arduinos and all kinds of cool stuff like that. And lastly, I flagged protobuf to talk about. I didn't like protobuf when I first encountered it. It was a bit forced upon me in a situation where, in retrospect, it wasn't really called for. I build a lot of APIs where we ship around JSON. JSON is the format. I expect most listeners know about it. It's so ubiquitous, some of you might know about it without knowing about it, or not be able to tell the difference between some JSON code and some Python code, because there are many situations in which they're actually the same thing, which is handy. So it's great having a JSON API. You can do some of the requests in your browser as you build stuff. You can have one of these fun Chrome plugins to do your post requests, or to become a wizard at curl and do them at the command line. It's quasi-human readable. You can get tools that format it in pretty ways or make it fold up. I love working with JSON. But when, and protobuf, as I understand it, came out of Google. And you can imagine there, the scale of what they do means sometimes if you pinch a few pennies, it's rather worth it. So if you think about those JSON APIs, what happens? Well, you've got a programming language that has some object in memory, has to be serialized out to the JSON format. And that's relatively easy. By human standards, it probably processes a single entry very fast. You can't tell the difference between 10 milliseconds and 1,000 milliseconds. I mean, yes, you can, but when it's that fast, we rarely think about the timing of it. But then, yeah, you need to run a bunch of them at scale, and suddenly it's slow or eating up too many resources, because essentially you're shipping a string over the wire in ASCII format or UTF-8 or however it is. Gets to the other end, and there's a process there that has to deserialize it. Turn that string into some JSON code, probably validate it along the way, depending on what language is loading it, convert it into objects. And there's just all a bit of overhead. So protobuf is this neat idea that kind of cuts the fat on that. It does a bunch of fancy things like not passing strings, passing, bytes, and being smart about the ordering and stuff like that. So even if you name your variable something long, they're secretly translated into some private ID, and that's translated just as an integer then, not a string, so much more efficient and easier to transform on the other end. So pretty cool, good stuff. Can be quite annoying if you get bogged down in integration tests, but my thoughts aside, protobuf's neat, and if you're doing high volume, high velocity stuff, you ought to be considering if it's a part of your data pipeline. All right, without further ado, let's get into our interview.
My name is Prasanth Pulavarthi. I work at Microsoft. I lead the product management team for our AI frameworks, which includes Onyx and a bunch of other open source frameworks that we contribute to.
Well, I'm excited to talk about Onyx especially, but can we hit on some of the bullet points of what some of those others are?
So we contribute to PyTorch, and we contribute to TensorFlow as well, and a little bit of scikit-learn.
Very neat. You got them all, I guess. So for listeners who may not yet know, what is Onyx?
So Onyx is a common standard format for machine learning models. It was actually developed by a number of companies in the industry, including Microsoft, Facebook, Amazon, NVIDIA, Intel, a whole host of companies that put together this standard format for representing deep learning and machine learning models. So you can train your machine learning model in TensorFlow or PyTorch or scikit-learn or MXNet or Keras, and you can export or convert those into the Onyx format. And that kind of gives you interoperability and portability of your machine learning model.
Why would I be interested in some portability of the model?
A couple of reasons. One, it helps you pick kind of the right tool for the job. When you're doing training, you want to have certain characteristics in your tool. Flexibility, agility, distributed training, etc. When you want to go deploy that to a production environment, whether it's on the cloud or even on the edge, you're going to be looking for things like high performance, good memory and resource utilization on the device, potentially cross-platform API if you want to deploy to different types of operating systems or different type of platforms.
I'd love to talk a little bit more about that deployment use case. I mean, it's an achievement to build a deep learning model for sure. Pat yourself on the back if you get that far. But once you've gotten there, you really have to just do something with it now, whether that's make it an API or put it in a device, or what are some of the options people have for making use of the models they train?
Yeah, it's always a challenge where you spend a lot of time and energy and effort to create this awesome machine learning model, and then you're trying to figure out, well, how do I deploy it? Whether you're deploying to the cloud or to an edge device. Oftentimes people will, the shortest route for them will be to deploy it as a pickle file. You just package up your Python code in a pickle kind of format and then ship it off somewhere.
Yep.
But that doesn't necessarily necessarily always work. On certain devices, you can't really run that kind of a package. It may not give you the best performance. There might be security issues with that, etc.
Libraries that don't match.
Yeah, versioning issues,
Yes.
all sorts of craziness. So that's where Onyx can help. If you convert or translate your model into the Onyx format, then you can use the Onyx runtime, such as the Microsoft open source Onyx runtime, to run it on various platforms, whether it's Linux or Mac or Windows, whether it's on the cloud, whether it's on the edge. You deploy that same model in a multitude of places.
And the Onyx file itself, is it, well, first of all, is there any reason to look at it under the hood? And if so, what will I find? Like JSON XML, or what does it store as?
So technically speaking, the Onyx file is used as a protobuf format. So you can actually use a tool, open source tool called Netron to visualize the model, and you'll actually see the graph inside of it. So you'll see the different operations. There'll be like a convolution and a ReLU, or different operators that are put together in that graph. So you can certainly take a look, but for the most part, you don't have to. You just get the model from a couple of places. So there are different ways to get the model. You can use some of the pre-trained models from the Onyx Model Zoo. You can create a customized model using some services like Azure Custom Vision or Azure Machine Learning Automated ML. Those will output Onyx files for you that are customized for your data. Or you can convert your own model. Like you might have had a data science, you might be a data scientist, or your data scientist team at your company might have created a model. You can convert that. Or you can train a model from scratch using a service like Azure ML, and basically during the training convert it to Onyx.
Comparing the Onyx format to others, I'm thinking of I may cut out the name, not to be slanderous, but it was a nice idea. And one of the challenges was when you'd serialize to it, it would really bloat up pretty heavily. And that was prohibitive for a lot of people to use PMML in certain cases, especially when models grew in size. Do we face any similar challenges, or has Onyx optimized for those sorts of things?
Yeah, we did take a look at some of the things that were already out there, and so Onyx tries to address some of those issues. We don't use XML; we're using protobuf, so it's a binary format. The data in the model is pretty much the same types of data that you would have had in the original model. It's the network topology of your model as well as the weights. So there shouldn't be that much bloat compared to what your original model was. If you want to reduce the model further, you can do things like quantization, of course, to shrink the size of the weights even further.
And what will I find in the Onyx Model Zoo?
In the Onyx Model Zoo today, we have a number of models mostly around computer vision, although we're starting to add some models around other scenarios like natural language processing as well. You'll see our image classification models, you'll see object detection models, some things as simple as MNIST, which is kind of a hello world, to think more complex things such as YOLO v3 or SSD. We're working on getting a BERT model put in there as well.
And then how do I access that? Is it kind of just, does the analogy GitHub for Onyx, is that satisfied?
So the cool thing about Onyx is everything is open source. So if you go to github.com/Onyx, you'll see a repository for the spec, and you'll see a repository for the models. That's our model zoo. And then you'll see a repository for the tutorials. So there are a number of tutorials about showing you how to convert models from different places and how to run them in different places.
Are there any interesting use cases you can share where people have taken advantage of the format?
Onyx kind of came out of a need that we had internally at Microsoft. And then when we talked to other companies, we found that they also had the similar needs. And that's why we all came together and created the Onyx format. At Microsoft, we have multiple teams doing ML. Machine learning is used across our portfolio of products. It's used in Bing, it's used in Office, it's used in like the ink recognition in Windows, it's used all over the place. And different teams use different tools, different frameworks. Some folks are using CNTK, some people are using TensorFlow, some people are using scikit-learn. This variety of frameworks causes some problems where they certainly get the benefits of using the different tools that are best for their needs, but then we need to be able to operationalize and deploy those models in a way that is highly performant. And so that's where Onyx and Onyx Runtime help with that. So at Microsoft, we've seen strong adoption of Onyx Runtime, which is our open source inferencing engine for Onyx models. And it's being used in products like Bing and Office, even cognitive services. And they're seeing really good performance gains as well. They've seen between like 2 and 14x performance gain compared to the original model.
What are my options in terms of deployment at the edge?
We are actually able to run Onyx Runtime on a variety of devices. It works on Windows, Linux, Mac. It works with both x86, x64, and also ARM processors. It works with both CPU and GPU. We actually have it running on NVIDIA Jetson Nano, which is like the $100 board. It works on some IoT devices that come from Intel. It works on Raspberry Pis. So it works kind of across this fairly large spectrum of devices.
You'd mentioned the collaboration on how we got to Onyx. I'll call it an industry standard. I don't know if you'd apply the same label or not, but it almost needs to be a format people take interest in. Can you talk about who some of the partners are in that group and why we need that to get the format promoted and extended and things like that?
Onyx has been a really good collaboration, partly because all the companies who signed up for it have actually implemented it in some form or other in their products. So it's not just like a paper spec that everyone shows up to a committee meeting and says, yeah, this is good, and then does nothing about it. The companies that are part of Onyx have actually implemented it in their products. The original kind of founders, I guess, were Microsoft and Facebook and Amazon. But then we quickly got NVIDIA, Intel, Huawei, Tencent, Baidu, a number of companies. MATLAB is involved, a number of hardware startups as well. If you go to the onyx.ai website, you'll kind of see the full list of partners that have signed up to support Onyx. But it's a fairly wide spectrum. Everything from the software vendors to the hardware vendors to mobile vendors to cloud vendors. So it's kind of pretty broad spectrum.
One of the reasons a person might hold out adopting a technology is worried, what will it look like in 5 years? Do I want to invest in something and then it becomes the Betamax? How do you build on Onyx in a way where, I guess tomorrow there could be a great new publication that says replace ReLU with some other crazy activation function that for some reason can't be in there? Is that even possible, I guess? How do you put people's fears to rest when they're concerned about the future?
Yeah, a couple of things, I guess. One is it's an open format, so it's entirely open source, and if you have some awesome new operator that you want to add, you can always submit a PR and talk to the community and get it in there. It's not like a closed standard that you don't know how to influence. The other thing is there's some extensibility mechanisms built into the Onyx format itself. Onyx basically consists of a spec that defines how you construct the graph, or how you define the graph in the model, and it contains a list of operators that are kind of standard, that are part of the spec. You can always add new operators to that list of ones that we already support. We also have a concept of domains, where you can have your own custom operators in your own domain to try it out, for example, while you're waiting for it to become part of the standard domain. There are these different extensibility mechanisms that allow you to never be blocked by something not being in the Onyx spec. You can either extend it by contributing a PR, or you can extend it temporarily, in your own custom usage, and then push it into the standard. If you want to get started with Onyx, you can go check out our URL for the Onyx Runtime, which is actually aka.ms/Onyx Runtime. And that goes to a page that talks a little bit about Onyx, the format, and also talks about the Onyx Runtime. The Onyx Runtime is kind of where the standard meets the hardware, right? It's actually the engine that does the high-performance inferencing. Like I mentioned, it's cross-platform, so you can use it in your different applications, whether you're deploying on a Linux web service or you're deploying to a Windows application. The Onyx Runtime is also built into Windows as part of Windows ML, if you've heard of that. It's deployed on many machines, and it's also used extensively, like I mentioned, at the Microsoft services, such as Bing and Office, etc. If you're wanting to do high-performance inferencing of machine learning models, you should try out Onyx Runtime.
Runtime, then, as you mentioned, runs anywhere, which is very appealing. What flavor do I get it in? Is it a Docker container or a library, a DLL? What am I working with?
Yeah, so there's multiple flavors. Whatever floats your boat, I guess. It's open source, so of course you can go to GitHub, github.com/Microsoft/Onyx Runtime, and get the source and build it yourself. It's also available as wheels on PyPy, so you can do a pip install Onyx Runtime or pip install Onyx Runtime-GPU, and you can make use of the Python API to load a model and run the inference. Or you can get it as a NuGet package if you're a C# developer and you want to use that. There's also C APIs and C++ APIs for you to use if you want to incorporate it into your application. We also are publishing Docker container images for use on Azure. So if you're using Azure ML and you want to deploy your model to the Kubernetes cluster and you want to use Onyx Runtime, there's some pre-built container images for you that have that. The container images come in a couple of flavors. We have some that are integrated with NVIDIA TensorRT, some that are integrated with Intel ngraph and OpenVINO as well. So we've actually partnered with NVIDIA and Intel to integrate these accelerators that they have into Onyx Runtime. So the cool thing is Onyx Runtime supports any Onyx model. It supports like the full breadth of the spec. But we also integrate with the different accelerators from the hardware manufacturers. So you kind of get the best of both worlds. You get the full compatibility with the spec, but we also accelerate as much of the model as possible with the capabilities that are available on the hardware.
When the hardware is present.
That's right.
Very neat. So I can just, do I have to configure that in any way, or is it sort of?
You have to install that version that has the appropriate software from the hardware manufacturer, but your API doesn't change. So when you're calling the inference engine, that API is still the same. It's still the load model and run the inference session. So you don't have to worry about kind of what the underlying accelerator is. Your program can stay the same, and as long as you just install the appropriate version, you're good to go.
Well, thank you so much for taking the time to have this discussion and share all your insights.
Sure, it's been great being here. Thanks so much for talking to me.